Right. Good. So now we are all set to start the session. Okay. So one second, I lost my pen in this. Okay, I got it. Perfect. Cool. So let me share my screen and we will start the session.
Okay.
Okay.
All right.
So this is going to be a quick recap. I hope you are able to see it.
Yeah, I can see
Yes,
the
right?
screen. Yeah.
Okay, perfect. So we were we have in the past we have discussed about the OSI model, the
Yeah.
subnetting, the VLANs, and
Subnetting was the physical.
those converting those into binary and
Yeah.
all those stuff is the
Okay.
is the subnetting. OSI model is those things which
Yeah,
is
I remember.
yeah,
Transformation layer,
which
network
is the
layer, transit
application,
layer, application layer.
correct,
Yeah.
application layer, presentation layer, session layer, okay, and what else? Oh, session, transport layer, network layer, data link layer, and physical layer.
Yeah.
Okay, so these are the OSI model which we have discussed about. Subnetting is those things which we have discussed. VLANs, you have good experience, so I think you will never
Yeah.
forget VLANs.
Yeah. It is like the logical connection.
Correct. And now we are into the STP, which is spanning tree protocol.
Yeah.
Okay, so we are where we are going to spend a good amount of time here in understanding what is spanning tree and all. Okay,
Yeah. Yeah.
so first things first, we need to understand why spanning tree. I mean, all these things we have already discussed, but I am doing it once again just as a refresher because it's been 1 month since we did all of this stuff.
Yeah.
Okay, so why spanning tree? This is the first question which we need to understand. Okay, so basically, when you connect the switches, okay, so let's say I have a switch named switch 1, okay, and I have another switch named switch 2,
Yeah.
and another switch named switch 3,
Yeah.
and switch 3 is connected to switch 1 and switch 2. Okay, so if you see here, everything is looks good. Okay, so that means for the switch 1, there are some downstream devices which are PCs, and for the switch 2 also, there are some downstream devices which are PCs. So everything is good till this point, but the problem comes when we are going to block this one of the ports. Okay. So which means, for example, let's say if this link goes down, what is the way for the so the link between switch 3 and switch 1 goes down, then the switch 1 and the devices connected to the switch 1 lose this entire connectivity to the world. Am I right? They don't have
Yes.
alternate path. Am I right?
Yeah.
Correct?
Yes.
Perfect. Okay. So similarly, for example, so this case we have seen the link between switch 1 and switch 3 going down. Similarly, if this link between the switch 3 and switch 2 goes down, then again the switch 2 and the devices connected to the switch 2 will lose their connectivity to the world, right?
Yeah.
So in short, this phenomena is called as single point of failure.
Single point.
Single point of failure. That means if one link goes down or if one device goes down, then we will lose the entire connectivity, single point of failure.
Oh, okay.
Okay. So
Yeah.
now, in order to tackle this, so the problem is single point of failure. Okay.
Yeah.
And the solution for that is redundancy or adding redundant. So I'll keep it little clear. Adding redundant link, adding the redundant links. Okay. So what I mean by that is now I'm going to add a link between switch 1 and switch 2 as a redundancy. Okay.
Okay.
So now what happens when I do like that is if the link between switch 3 and switch 1 goes down, switch 1 can still reach to switch 2 devices using the link number 2. So if the link number 1 is the link between switch 1 and switch 3, and if the link number 2 is link between switch 1 and switch 2, okay, if the link 1 goes down, then the link 2 will be the redundant link which we are going to use. That means there is no single point of failure, right? If this link goes down, if the link 1 goes down, we have link 2 as a
Yeah.
backup, correct?
Yes.
So our problem number 1 is solved, right? Correct?
It's yeah.
Do you agree with that?
Yes, I do.
Exactly. Okay. But this solution which we are introducing, that means adding the redundant links, is creating one more problem. Okay. And that
Okay.
problem is called as broad. So there are three categories to that, which is called as broadcast storm. And the second problem is MAC address table instability. Instability. And the third problem is duplicate packets.
Duplicate.
Duplicate packets.
Oh, okay. Yep.
Okay. So let us understand these three problems which this redundancy is bringing in. So first problem is single point of failure. For that single point of failure, we are adding the redundant links. And that redundant links is creating us three problems, which is broadcast storm, MAC address table. It's not just MAC address instability, it's MAC address table instability. Table
Okay.
instability. Okay. And the duplicate packets. Okay. So this particular one, let's understand each problem in detail. Okay. Because we need to understand all the stuff. First is broadcast storm. So what I mean by broadcast storm is storm, not storm. Okay, spell it. So let's take the topology once again. Okay, so where we have switch one. 1 second. I hope you are able to see it, right?
Yeah, yeah, I can see
You
it.
have
Yes.
okay, perfect. And then switch three here. Okay, and then the links connected like this. Okay, so this is a wonderful diagram which we have. Okay, perfect. So I will name these as switch 3, switch 1, and switch 2. The same like our abort topology. Okay, so now I'll keep this as link number 1. The link between switch 1 and switch 3 as link number 1. The link number switch 1 and switch 2 as link number 2. The link between switch 3 and switch 2 as link number 3.
Yeah.
Okay, And the switch 1 is connected to some of the PCs in the downstream, and the switch 2 is also connected to some of the links in the downstream, some of the PCs in the downstream. So now what is happening is, let's name these PCs as 1, 2, 3 connected to the switch 1, and 4, 5, 6 connected to the 4 and 5 and 6 are connected to the switch 2. So now what is happening is, switch 1, okay, is sending us a broadcast packet. Okay, what happened? Switch 1 is sending us a broadcast packet. Okay, you understood, right?
Yep.
What is
From
broadcast packet?
from BC1.
Correct. Okay, so this broadcast packet means, what does this? So this says is, this is a broadcast. Okay, so what does? There are three types of packets. First one is broadcast packet. Second one is unicast packet.
Yeah. And multitasking packet.
Correct. Third one is multicast packet.
Yes.
Okay, broadcast means send to everyone,
Yep.
everyone in the network. Okay, unicast means send to one person, one specific person or one specific device. I think in networking context, it's device. Okay, multicast means send to specific group of people,
Okay.
specific group of devices, specific, not all, but specific group of devices.
Yeah.
Okay,
Like the HR, like the marketing, like a
correct,
department.
correct, correct. You are absolutely correct. Okay, so now the broadcast packet has been received by the sent by the switch one to switch. Sorry, PC1 to the switch one. Okay, as per the rule, the switch one is supposed to send this particular packet to all the links which it has, which
Yeah.
means it will send it to the switch number 3. It will send it to switch number 3, this particular broadcast packet, and
Yeah.
also it will send it to switch number 2, and also it also sends it to the PC2.
Yep.
Correct, am I right?
Yes. Every device in
And
the
also to the PC3, am I right? So this
yes.
topology makes sense to you?
Yes.
Perfect. Okay, so switch 1 is sending it to switch 3, switch 1 is sending it to switch 2, and switch 1 is sending it to the PC2, and switch 1 is sending it to the PC3.
Yeah.
Okay, and now switch 2 has received the packet. Okay, one of the packet from the switch 1, which is a red color packet which I have highlighted. Now responding to this particular one, it will send this particular packet to PC4,
Three, 4, 5, and 6.
PC4, 5, and 6. Wonderful. PC4, PC5, and PC6. And also, it will send one packet to the PC3. Am I right?
Yeah.
One second. One packet to switch 3.
So it's which three does not have like in user devices. It's just like
But
a
it might have, but
okay, I
I
get it.
didn't wrote it because that is irrelevant. I mean, not that much relevant to our use case. Okay, so
Okay.
it can also have. Okay, it's not like right now I don't require it. That's why I'm not writing it. Okay,
Okay.
perfect. Okay, so now switch 3 has received two packets. One from the switch 1 in the first step, and once the switch 2 has processed it, that switch 2 also is sending the same packet. If you see, all these are the same one packet which is being multiplied multiple times. So switch 1 has multiplied it here, like all these packets are The same packets, like it has generated it four times. That means one packet, it made it as four, it made four copies out of one packet, and one copy it has sent it to switch 3, one copy send it to switch 2, one copy to PC2, and one copy to the PC3. So, correct?
Yeah.
And switch 2, when it receives, it made again four copies of it, and four among those four copies, it has sent one packet to PC4, one to 5, one to 6, like PC5 and PC6, and another
Yes.
copy it has sent it to switch 3. Now, switch 3 has received two copies of that packet, which is been generated by the PC1, one from the switch 1 and one from the switch 2. Correct?
Yes.
You agree, right, till now?
Yeah. I agree with you.
Perfect. Okay. Now, let's see how does the uh, switch 3 process it. Okay. Let's see what does the switch 3 does with the packet received from the switch 1. So, what it will do, it has received the packet and it is a broadcast packet. So, it has to send it to all the devices. Okay.
Yeah.
Currently, we only have one link, which is between uh, switch 3 and switch 2. That is the only link which is there. Okay. So, that means the switch 3 is going to send that particular packet
Back to switch
to the
two.
switch 2. And also, there is one more copy which has been received by the switch 2 from switch 2 to switch 3. So, responding to that, what will the switch 3 do? It will send that particular packet on this link. You agree with me?
Yeah.
Is it clear till this point?
Yes. It will
Okay.
receive and it will send at the same
C-
time.
correct. Okay. So now if you see observe closely, this particular packet is being initiated by the switch one. Correct?
Yes. Yeah.
And in a loop, it came back to the switch one, same copy. Correct?
Yeah. It
And now
make
what
back to
happens?
switch. But yeah, I get it. I see it now.
Yeah. And what happens? This loop which you are seeing, that means now what happens? Switch one has received it. So what will the switch one do? Again, it will send it to all of its ports. So it will send it. So if you see, very funnily, I mean, switch one has received this green color packet, right, from the switch three, like
Yes.
this one. I don't know whether you are say able to. Switch
Yeah.
three
Yeah.
has
Yeah. I
sent one
see.
green color. Okay, perfect. Okay, so as a response to that, it has to send it to everyone, right?
Yeah.
Correct. So
Yes.
switch one is sending it as a part of that. Switch one is sending it to PC one, and if you see, funnily, PC one is the requester of that packet, and we are sending that packet to the PC one. See how is this? It's not efficient, right?
It's
Correct.
not efficient. Even though originally the message came from BC1, it came back
Again, we
as a
are saying
message.
correct. So it's like you are sending a letter or you are sending a message stating that please deliver it to everyone, and you are receiving your own message.
Yeah.
That is wrong, right? That should not happen.
Yeah.
Correct. And
Yes.
also we are sending again multiple the same copies of that to the PC3 and PC2, and also one more packet to the
To switch to.
switch 2. And if you see, this is not going to stop, because again switch 2 receives that packet. It will create the four copies of it, send one packet to switch 3, remaining three packets to the PC4, PC5, PC6, and this loop will never stop.
Yeah, I got
Understood?
it. Yes.
It keeps on revolving. Switch 1 will send it to switch 2, switch 2 will send it to switch 3 will send it to switch 1, and that loop continues. It will be forever. And what happens, because I mean this is called as broadcast stop. Okay, that means if there is
Yep.
a broadcast packet, that will create these multiple copies, and that is called as broadcast stop. And this is also called as, so why this is happening, because here we have a loop.
Yeah. The
Okay,
circulation
so
of
that
the
means if
information.
correct, if you see, there is no, let's say if your packet is inside this triangle, there is no way for this packet to come out, right? For
Yes.
example, let's say if there is the correction like this, if the packet goes, if you leave the packet here, it can easily come out like this because there is a space between these two, correct?
Yeah.
Okay, but if your connectivity is like this, and if you're leaving your packet here, is there any way where the packet can come out?
No, it's going
No.
to circulate into that area. That's it.
Exactly. So the boundary is going to be this thing. So this is called as a loop. Okay. So this is called as technically a layer 2 loops. So by introducing this redundancy, so for problem number one was single point of failure. That's
Yeah,
why so if you see this particular diagram which I have driven written, so this is our first problem. This is called a single point of failure, right?
yeah,
But when we leave the packet here, it is easily able to come out. That means there is no loop here,
yeah,
correct? But
yes,
to solve that single point of failure, we are the people who introduce this law.
yeah,
And because of that, what is happening is the packet is not able to come out and it is circling inside that loop.
yes,
So that means the problem which that redundant link has created is the L2 loop. Understood?
yeah. Layer two.
Layer 2 loops. Okay. So this
Okay.
problem is been categorized into three things. I mean, one word is layer 2 loops. And what happens if you have layer 2 loops is you'll see the broadcast storm and you see the duplicate packets. If you see the switch PC2 has received two copies and it
Yeah,
will not stop. It will keep on increasing.
yeah,
Okay.
yes,
So your broadcast storm will happen, which means that broadcast packet will continue to revolve, and at one point the switch can crash also because see, at a point you can only process certain information. Your devices doesn't have unlimited resources. Agree?
yes,
So in that particular case, what happens when your packets are getting multiplied, like multiplied, and number of packets are increasing? At one point, your device resources will not be enough to process those information. And what happened? Your laptop, your switch will crash. That's what happens, right? Even in our laptops. Like let's say you are opening so many amount of applications on your laptop,
yeah,
which the laptop cannot handle. Then what happens? It hangs. That's it. It hangs and it will not be responsive to you, right?
yes.
Correct. So that's
Yeah,
what
you're right.
is the broadcast storm and the duplicate packet. Okay. So
Yeah.
one more thing is the MAC address table instability. Okay. So let me explain you on that one. I hope you understood
No, I
these
get
two
this concept.
aspects.
I get the
Okay.
L2 loops. I get that concept.
Okay. Broadcast storm.
I get it. Yes. Uh,
Okay. Duplicate packets, like how the duplicate packets are generated. That did you understood
yes.
that?
Yes. It is
Okay.
like the
Perfect.
circulation of the package between the
Perfect.
switches and the in devices at the same time.
Perfect. 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 Okay. Now let's see the MAC address table instability. Okay.
Yeah.
So yeah. How much more time do we have in this session?
Probably less than 10, probably less than 5 minutes.
Less than 5 minutes. Okay.
Thanks.
Perfect. So I think in less than 5 minutes, I cannot explain about this thing. Okay. So we will meet in the next session. And by the way, uh, because it's been long time. Okay. So
Yeah.
you have already paid me the amount, right?
Yes. I
For
paid
that
you
amount,
250.
exactly. For that amount, you have still 50 sessions in the queue.
Okay.
Okay. So that means you already paid me for 50 sessions. So till this 50 sessions are over, you can relax. Like relax in the sense, if you have money, you can pay. Otherwise, if the budget is tight, you can relax. Okay.
Yeah. Okay.
Perfect. but you
Yeah,
have up to 50 sessions. Okay.
yeah, that's not this Friday. The next Friday I will pay.
Yeah, yeah, take your time.
Yeah,
I mean, you already paid me for 50 sessions, so 50 sessions will take time to complete. Like what I'm trying to say is, if you have amount in the bank, and if it is okay for you to share me, share me. But if you have your finances which you need to take care of, you can take care of because you already paid me for 50 sessions.
yeah. Okay, I get it.
Okay, so it's up to you. Okay, whenever you want to share, whenever you want to send the money, and I'll increase this counter whenever you send it. Okay, but if you have, let's say you want to do something with your money, you can happily do it because you already paid me for the 50 sessions.
Okay,
Okay, so it's up
okay,
to
okay.
you. Okay, whether you want to share, I mean, send or not. Okay,
No, no, I understand.
yeah, perfect. Okay, so we will meet in the second next session. Okay, so I will keep the counter track of this counter. So just now we completed one session among the 50.
Yes.
Okay, so we still have 49 more sessions left. Okay,
Yeah.
perfect. Okay, so you are okay with one more session, right?
Yeah, yeah, we can have another session. This is a good class.
Okay, so we will meet in the next session. Okay,
Okay, so
perfect. Good. Okay, so please, I think you have to wait for 10 minutes, right? Before the
yeah.
another session.
Do I need to close it before you save the notes?
No, you can close it. You can close it. Okay,
Yeah, okay.
okay,
All right.
cool.